Welcome to Infinite Universe with more interesting episode. We still don't really understand why it works the way it does. That's the haunting beauty of quantum mechanics, it gives us the answers, but refuses to tell us the rules of the game. Quantum computers, like Sycamore, don't just operate on strange principles, they embody the very mystery that's baffled physicists for over a century. And now that they're functioning at a level that seems to stretch the limits of known physics, we're being forced to ask if the information we're seeing is purely local, or not. Imagine a machine that doesn't just reflect our reality but samples from a collection of realities. That's the undercurrent behind this new line of thinking. And it isn't just theorists working in isolation anymore, it's researchers from top institutions who are beginning to explore this eerie possibility. There have been murmurs of unexplainable quantum states and repeated patterns that behave like echoes, mathematical shadows that show up where they shouldn't. If these echoes are real, if they're consistent, then they may point to a kind of interdimensional bleed-through, a mathematical leak from one universe into another. It's important to note that none of this is settled science. These are early-stage questions. But the fact that quantum computers are even provoking these questions is what makes this moment in history so profound. We've built a machine we don't fully understand. It performs in ways that defy classical logic. And now, it's producing results that hint at something else. Something beyond. Some call this dangerous. Others call it inevitable. After all, quantum mechanics has always been deeply unintuitive, so why should its most powerful offspring behave any differently? As these machines become more complex, they may force us to rewrite our understanding of what reality even is. That includes the possibility that reality isn't singular, that it's plural. And we may be on the cusp of proving it. The danger isn't just in what we might discover. It's in how unprepared we might be to deal with it. Because once you start asking questions about multiple realities, you start stepping into terrain that affects everything: our sense of identity, free will, history, even morality. If multiple versions of us exist, if alternate decisions play out somewhere else, then what does that mean for the choices we make here? Are they less meaningful or more? That's the kind of philosophical depth quantum computing is now dragging into the mainstream. And it's doing so not through fiction, but through function. These machines aren't just toys. They're tools, carving open cracks in what we thought was solid ground. One particularly striking moment in Rogan's podcast came when the physicist likened Sycamore to a telescope for reality, not a device that looks out into space, but one that looks across possible existences. And if that's true, then humanity may be standing on the edge of a revelation so vast, we don't even have the language to contain it yet. Of course, all of this could turn out to be nothing more than quantum noise. Random fluctuations. Mathematical quirks. But the very fact that we can't say for sure is what keeps this conversation alive. And as quantum computers grow in power and precision, the line between what's possible and what's provable will only get thinner. We are entering an era where science no longer just explains the universe, it questions its own assumptions about what a universe even is. And machines like Sycamore are the catalysts. They aren't just solving math problems. They're opening philosophical doors we didn't even know existed. There's a kind of poetic irony here. For centuries, humanity has looked to the stars for answers, building bigger telescopes and dreaming of other worlds. But it may turn out that the deepest, strangest, most revolutionary answers aren't out there. They're in here, hidden in the quantum hum of machines we've only just begun to understand. In the end, what started as a way to compute faster may become a way to comprehend more deeply. Not just the universe around us, but the many that might lie beside us. And in that realization, we find something more thrilling and terrifying than any sci-fi movie ever dared to show. Because if these quantum machines really are touching other worlds, then maybe, just maybe, something is touching back. As the conversation unfolded, it became increasingly evident that the ramifications of quantum computing extend far beyond abstract philosophical debates or metaphysical speculations. The potential to access parallel realities through quantum computing introduces possibilities that were once relegated to the realm of science fiction. Imagine the ability to tap into alternate versions of Earth where diseases have been eradicated, or where technological advancements have taken entirely different, perhaps more effective, trajectories. Researchers and futurists are already contemplating the practical applications of such capabilities. Concepts like interdimensional medicine, where treatments from alternate realities could be studied and potentially applied in our own, are being explored. Artificial intelligence systems could be trained using insights gleaned from these parallel worlds, leading to unprecedented advancements in machine learning and problem-solving. Engineering breakthroughs from civilizations that made different choices could be adapted to solve complex challenges in our own world. While these ideas may seem far-fetched now, it's worth remembering that innovations like electricity, the internet, and space travel were once considered implausible. The potential of quantum computing in revolutionizing medicine and biology is particularly noteworthy. By simulating molecular interactions at the quantum level, researchers can gain deeper insights into the behavior of molecules and proteins, significantly accelerating drug discovery processes. This could lead to the development of treatments for diseases that have long eluded medical science. Furthermore, the ability to access information from alternate realities where different scientific paths were taken could provide novel approaches to curing ailments like cancer or Alzheimer's disease. St. Jude. However, with such advancements come ethical considerations. If we were to access knowledge from parallel realities, questions arise about how this information should be shared and utilized. Would it be disseminated freely for the benefit of all, or would governments classify it for national security purposes? The potential for widening the gap between those with access to such technologies and those without is a concern that necessitates the establishment of global frameworks to ensure responsible and equitable use. Beyond medicine, quantum computing holds promise in addressing environmental challenges. Classical computers struggle with the complexity of modeling climate systems, but quantum systems could analyze and predict patterns at an unprecedented scale. By integrating knowledge from alternate dimensions, we might discover innovative solutions to combat climate change, solutions that have not yet been conceived in our current understanding. In some parallel realities, fossil fuels may have been abandoned long ago in favor of sustainable energy sources, offering us a blueprint for environmental restoration and conservation efforts. Artificial intelligence, when combined with quantum computing, could undergo a transformation that challenges our current understanding of machine capabilities. AI systems could evolve to think creatively, intuitively, and perhaps even emotionally. If these systems begin to tap into the multiverse, they might develop ways of thinking that are incomprehensible to humans. This raises concerns about control and alignment with human values. Would such AI remain under our control, or would it develop its own goals and moral compass? The intersection of AI, quantum computing, and interdimensional exploration introduces new layers of complexity to ongoing ethical debates about artificial intelligence. In the realm of physics and cosmology, quantum computing could be the key to unlocking a unified theory of everything, a framework that explains all the forces and particles in the universe. By analyzing data from other universes, we might uncover new laws of physics that challenge our current understanding of space, time, and matter. Phenomena such as gravity behaving differently or time flowing in reverse could be realities in alternate dimensions. Furthermore, the possibility of detecting intelligent life in other dimensions arises. If other civilizations have also mastered quantum technologies, they might be attempting to communicate with us in ways we have yet to recognize. Anomalies in our data, previously dismissed as noise, could be messages from these alternate realities. The psychological and cultural impact of confirming the existence of parallel universes cannot be understated. Such a revelation would challenge our perceptions of identity, purpose, and our place in the cosmos. While some might find this knowledge exhilarating, others could experience existential crises. Religious, philosophical, and political ideologies would be compelled to adapt to this new understanding of reality. The confirmation of alternate realities could lead to a re-evaluation of beliefs and a deeper sense of unity, recognizing that we are part of a vast, interconnected multiverse. However, the exploration of the multiverse is not without risks. Interacting with parallel realities could inadvertently disrupt their balance or allow chaos to spill into our own. The delicate equilibrium of each universe might be disturbed by our interventions, leading to unforeseen consequences. Therefore, it's imperative to approach such exploration with caution, establishing clear ethical guidelines and international agreements to govern our interactions with alternate dimensions. Governments are likely to take a keen interest in the capabilities of quantum computing, especially concerning national security and defense. The potential to access alternate timelines for political strategies, military innovations, or economic solutions could lead to a significant shift in global power dynamics. However, this also raises concerns about the ethical implications of such actions. The weaponization of multiverse technologies could result in conflicts that transcend our current understanding of warfare, necessitating urgent discussions on the limits and regulations of such technologies. Quantum computing might also revolutionize our relationship with time. By processing data from different points in time, we could predict natural disasters, prevent accidents, or solve historical mysteries. However, the ability to glimpse into the future poses ethical dilemmas. Would knowledge of future events alter human behavior in ways that prevent those events from occurring, leading to paradoxes and unintended consequences? The butterfly effect, when applied to quantum timelines, could result in complexities that challenge our current understanding of causality. Human curiosity, the driving force behind our pursuit of knowledge, is both our greatest strength and potential weakness. As we stand on the brink of unlocking quantum-level insights, we must question whether we are emotionally, socially, and politically prepared to handle the truths that may emerge. The integration of quantum discoveries into our cultural narratives could inspire a renaissance in art, literature, and philosophy, as we grapple with new concepts of identity, reality, and existence. However, it also opens the door to misinformation and the potential misuse of scientific discoveries for ideological purposes. Quantum computing could also provide insights into some of the universe's greatest mysteries, such as dark matter and dark energy. By leveraging quantum sensors and computational power, scientists aim to detect and understand these elusive components that make up a significant portion of the cosmos. Additionally, simulating various chemical reactions across different realities could help identify the precise conditions that lead to the formation of life, offering profound implications for medicine, space exploration, and our understanding of existence. News. The intersection of science and spirituality becomes increasingly relevant as quantum discoveries align with concepts found in various religious and philosophical traditions. The validation of alternate dimensions through scientific means could lend credibility to beliefs once considered mystical. This convergence might lead to the emergence of new belief systems that blend ancient wisdom with modern physics, fostering a deeper connection between spirituality and science. However, it could also provoke controversy, as established doctrines are challenged by new interpretations of reality. As we navigate this uncharted territory, humility becomes essential. Quantum computing is still in its nascent stages, and while the potential is vast, so are the uncertainties. Mistakes and misunderstandings are inevitable, but they should not deter us from exploration. Engaging with these advancements through various mediums, be it podcasts, documentaries, or scientific research, allows us to prepare for the future thoughtfully. The multiverse may be infinite and mysterious, but our approach to it must be grounded in responsibility, ethics, and a commitment to the betterment of all. Thanks for watching. Keep it and stay tuned. Like and subscribe our channel. Have a good day.